Assalamu alaikum friends, I hope you're all fine. So we are doing the projectile motion and we have done case 1 and now we're going to do case 2 and we will discuss what the motion of the projectile be if we throw it at any angle theta. So in this case we're not giving it any initial horizontal velocity, sorry. We will only give a velocity which has both the horizontal and vertical component. Okay, the diagram for this case will be like this. As you can see that the initial velocity vi that we gave has both vix and viy component. The ball goes up and its velocity goes on decreasing to 0, and at the highest point it becomes 0. Again, when it goes down, its velocity goes on increasing, and at the point when it is just about to hit the ground, not at the ground but just about to hit the ground, it has the same velocity that we gave it. Okay, because we know that at the ground it will become 0. Okay, so let's do some calculations. We gave it velocity vi, and the beauty of the physics is that you can find the final velocity of the object by knowing only its initial velocity. Not only, you also need to know some other factors. So by using the first equation of motion, Vf is equals to Vi plus At, because we have to find the final velocity from the initial velocity. So we will use this formula, and this formula can also be derived from the acceleration formula. Okay. So as we know, okay, so let's do that in the x-axis. It will become Vfx is equals to Vix plus Axt. As we know that the acceleration in the x-axis is 0. Acceleration in the x-axis is 0, always 0. You're not pushing the ball again and again to accelerate it. You have just leave it. By giving only an initial velocity, you left it to the Earth's gravity. Okay? We gave no initial acceleration to it, only uniform velocity. So Ax is equals to 0, which makes t also 0. And we are left with Vfx is equals to Vix only. And what is Vix? Vix is the component of velocity in the x direction. And from the trigonometric ratio, we know that Vfx is equals to Vi cos of theta. Okay. Now for the y-axis, Vfy is equals to Viy plus Ayt. Okay. And what is Viy? Viy is the component of velocity in the direction. In the y direction. From the trigonometric ratio, we know that it becomes Vi sine of theta. And what is Ay? Here, look, what is Ay? According to the convention, we take a positive sign when things are going down. But here, we're making the ball go up against the Earth's gravity. So we'll take a negative sign with it. So it will become Vfy is equals to Vi sine of theta minus gt. Now we have to find the magnitude of the velocity, that how much velocity we gave to this ball. Look here, we have a perfect right angle triangle. So by using the Pythagoras theorem, we will use v square is equals to Vfx square plus Vfy square. By taking the under root on both sides, we will have v is equals to under root Vfx square plus Vfy square. Putting the values from the equation 1 and equation 2, we have Vi cos of theta whole square plus Vi sin theta minus gt whole square and whole under root. And from the trigonometric ratio, we know that cos square theta plus sin square theta, it becomes 1. And from the trigonometric ratio, we know that cos square theta plus sin square theta is equals to 1. And here we take the gt as common, and it becomes v is equals to under root Vi square plus gt whole gt minus 2 Vi sine of theta. So this is the magnitude of velocity that you gave, and we'll find it by its components, Vfx and Vfy component. Okay. Now to find the angle, what you have to do is you have to take a trigonometric ratio. You have to use trigonometric ratio tan of theta. Tan of theta is equals to perpendicular over base. What is the perpendicular here? Vfy is the perpendicular. And what is the base? Vfx is the base. So putting the values Vfy and Vfx, we got tan of theta is equals to vi sin theta minus gt over vi cos of theta. But we don't have to find tan of theta, we have to find only theta. So putting the theta here and taking tan of theta over the next side, over the other side, we have tan inverse of vi sin of theta minus gt over vi cos of theta.